Hey everyone, and welcome to another 3D revolution. In the last episode in my series of 3D printing and the environment, I looked at two different types of fully biodegradable filament, what the advantages of them are, and how their performance looks on paper. In this episode, however, I'm going to be putting their claims to the test, as I run a series of tests pitching the performance of both the biofilaments against two types of traditional PLA. The two biodegradable filaments I'll be talking about in this episode are NonOilen by Fillamentum and Alga by 3D Print Life. Both of them are fully compostable, 100% biodegradable, and they've got some unique properties of their own. Make sure you watch the previous episode of this series, which looks into both of these filaments in a lot more detail. In this episode, I'll be pitching both of these filaments against the Prusa Refill PLA and Fillamentiv's recycled PLA, both of which I've talked about in an earlier episode of the series. I'll be testing each of these filaments for strength, accuracy, texture, flexibility, and detail by printing the same model in each filament and then putting them under a figurative microscope. For strength and flexibility, I'll be printing a model which I threw together myself, which tests different areas of strength and flexibility. For accuracy, I'll be testing a test cube that was designed by Gray on printables.com. I'll pop a link in the description below. And for texture and detail, I'll be printing the Cali Dragon. So with that, let's get printing. So to start with, let's test the strength and flexibility of these filaments. For that, I've designed this part here, which has different features allowing for testing in both areas. This part has 4 wide areas of varying thickness, which will allow for the testing of flexibility with this filament. And at the end here, we have a hook. This part here will be clamped onto a desk, and an incremental amount of weight will be attached to the hook. And we'll be able to see then at what point, if at all, the part then breaks. Before starting the strength test and possibly breaking the part, we'll start with flexibility. Now, the flexibility isn't really an advantage or a disadvantage because it really depends on the application. You may want your filaments to be slightly more flexible and have a bit of give to it, or you might want it to be as rock solid as possible. So this is just a way of comparing the filaments to figure out if it's applicable to your use case. To get a fair reading, I'm using an on-screen protractor to measure the angle, and I'll be doing this at 4 different thicknesses, starting with 3 millimeters here. Now we've got 2 millimeters, so you can see that I'm applying pressure to the area that's being tested and holding the thicker area. We're now at 1 millimeters. You can see they're all bending significantly further now. And then we are at 0.5 millimeters, and you can see all of them are bending significantly further than they were at the earlier stage. So with those tests done, I've placed the results here in flexibility order, with PLA being the least flexible and NonOilen being the most flexible. At 3 and 2 millimeter thickness, they're all pretty much the same, with NonOilen being very slightly more flexible. And then as we go down to 1 and 0.5 millimeters, you notice more of a significant difference. Now, due to the way in which they were flexing, it wasn't all flexing at a single point. It was difficult to read the exact bend for 1 millimeter and especially 0.5 millimeters. So I tried to gauge roughly what that worked out as an overall angle rather than from a particular point on the protractor. But you can see there that whilst there is a bigger difference on the bios, it's fairly similar still. So let's have a look at the strength of these different filaments. Now I know there's different ways that you could test the strength of a filament, whether it be the amount of pressure it can take or the amount that it's pulled apart, and then the different axes that those different pressures and forces can be applied. But because this isn't an in-depth look at one specific filament, more a comparison to see how the same thing affects different filaments, I'll just be testing the one. And the way that I've designed this, printed laterally, is that it will test both the strength that it can hold before it physically snaps the actual extrusion of a filament, but it should also demonstrate how well the layer bonding is. If we start to see individual layers cracking as it's being pulled down, then it'll show that the bond isn't as effective between the different filaments. So let's get some weight hung off of them. We're going to increase the amount of weight hung off of each of these by 1.25 kilograms at a time. That's around 2.75 pounds. And we start here with 1.25 kilograms, and we've moved up to 2.5 kilograms here, 3.75, 5 kilograms, which is around 11 pounds, 6.25 kilograms, 7.5 kilograms, 8.75 kilograms, 10 kilograms, which is 22 pounds, and Alga has gone 11.25 kilograms, and at that point NonOilen has broken 12.5 kilograms, and the virgin PLA has broken, meaning that at 13.75 kilograms, recycled PLA is the winner. Well, there was definitely some surprises in the strength test there. People may not be so surprised that it was the biodegradable filaments that broke first, with Alga breaking at 10 kilograms and NonOilen breaking at 11.25 kilograms. However, they were both in the same ballpark as both PLAs. What may be more surprising is that it was the recycled PLA by Fillamentum that actually outlasted the PLA, the virgin PLA by Prusa, with Prusa's PLA lasting till 12.5 kilograms and Fillamentum's recycled PLA lasting till the stronger strength of 13.75 kilograms, which shows that using 87% recycled material as Fillamentum do, it's not going to necessarily reduce the quality or the strength of that print. So that's the strength tested. Next up, we're going to be looking at accuracy, and for that, I'm going to be printing these test cubes. So this is a 15 by 15 millimeter cube, so we can test the dimensional accuracy in the different directions, but also we can test for things like artifacting in different dimensions with all of the different cutouts in the different dimensions. Okay, so now let's start again with the Prusa Refill PLA, which is the most traditional of the filaments that we're testing and is a virgin PLA, so this isn't a recycled one. It looks like it's come out really nicely. There's no artifacting that I can really see there. The structure and shape is all intact. The bridging has worked well. The lettering is all distinct. So let's see how it comes out with dimensional accuracy. Well, that's spot on, 15 millimeters. That couldn't be more perfect. That's what this is supposed to be, and exactly 15 millimeters is what it is. Let's have a look at the vertical. 15.9, okay, let's say an average of 15.10. It's between 15.09 and 15.11 millimeters, so that's pretty close, but it's around 0.1 millimeters out in the vertical. Okay, so let's have a look at the recycled PLA. Fillamentum's recycled PLA also looks really good. There's again no distinct artifacting. Everything has come out sharply. There's no failures in the print. The lettering is all obvious there. You can see the lettering. The layering is all nice. There is a little bit of stringing that you can see here, and that is because with all four of these I've made sure not to clean them up after the print, because I want to show you how they come straight off the bed without days and days of calibrating to get the exact right settings. These are using the settings recommended by the manufacturers. Yeah, that all looks pretty good. So let's see how this comes out in terms of accuracy. So 15.05 millimeters. That's again pretty close. It's not spot on like the other one was, but that's pretty close. 15.05 millimeters. And let's have a look at the vertical on that one. Is 15.11, 15.13. It's around the same as it was for the virgin PLA, so we'll say 15.1 millimeters out on that. So let's have a look at the biodegradable filaments. First up again is the Alga filament, and you can probably see immediately that there are some flaws with this print. So that side doesn't look too bad. Most of the verticals have come out well there, but you get to this point, you can see a lot of stringing, and then we get round to this side, and you can see none of those vertical bars have come out at all. You can see it's failed in the middle there, and if we keep on moving around, you can see it all there. So this is what it's supposed to look like here, and it's just not worked out. But other than that failure, which I'm guessing is to do with interlayer bonding, it just had some sort of issue at that point. The rest of it actually looks really sharp and really clean. Let's have a look at what the dimensional accuracy is like. Well, that's pretty spot on, exactly 15 millimeters again. So this is like the virgin PLA, perfectly accurate in the x-axis, and we'll check it in the vertical in the z-axis. Well, that's actually 15.05 millimeters in the vertical, so that's actually the most accurate vertically in the z-axis that we've had of the 3 filaments so far. And finally is the NonOilen by Fillamentum. So this one, there has not been any failures like with the Alga one. All of the vertical bars on both sides have come out. It generally looks like a good print, but there is some evidence of artifacting. If I turn it on the side here, you can see it along this edge here. You can see a bit of artifacting there. But other than that, it looks a pretty crisp, clean print. Let's see how the accuracy has come out with this one. Okay, so 15.05 millimeters. So this is the same as a couple of the other ones we've had there. It's almost spot on. And let's have a look at the vertical again on this one. Is 15.09 millimeters. So again, it's in the ballpark of 15.1 millimeters out. For the x-axis, the Alga was actually the most accurate of the 4, but with the x and the y, they were all pretty much between spot on and 0.05 millimeters out, so they're all pretty damn accurate. Finally, I'll be looking at the texture and detail of these filaments, seeing how they perform retaining the detail of a model and what the look and feel is of the print itself. For that, I'll be using the Kali Dragon design, which is a quick and easy print, but features lots of different details so we can see how they come out. So we'll start out again with our benchmark of the Prusa Refill PLA. I've actually printed this model before in PLA, so I kind of knew what to expect, but it's good to have that comparison with the other models. The detail in the scales has come out really nicely. I really like that, especially in this color, which I believe is called the Galaxy Black. It's really nice. And then with the texture, so most filaments, especially PLA, comes out with like a sort of reflective smooth finish, and that has definitely come out here. It's got a nice smooth texture here. You can see on the cheek here is nice and smooth, and the antlers have both come out nice and solid, so the detail on that is superb. I really enjoyed that one. Next up is the Fillamentive Recycled PLA, and it's, to be honest, come out with a very similar effect as the Prusa one. Obviously, you've got to take into account that it's a different color, so it's going to have a different look, but in terms of level of detail on the scales here, it's spot on, no different to the Prusa there. And the antlers, I would say, potentially have come out even nicer. They're definitely very solid. There's no weaknesses there. It's all bonded well. So yeah, the details come out really nicely, and then the texture is just a nice standard smooth PLA finish. So again, really like the texture and the detail with the recycled PLA. Next up is the Alga by 3D Print Life, and it's come out again really nicely. The detail in the scales has come out nicely. There is a little bit of an issue with the top of the scales on the tail here, but I think that's due to the stringing, which I'm guessing is caused by their recommended temperature being just too hot for the filament. If you cooled it down and played with your retraction settings further, you would be able to fix that stringing, and I think the detail on these scales at the top here would come out great. But if you look lower down where that stringing wasn't an issue, the detail is spot on, so that's not an issue at all. And again, like with both of the PLA ones, the antlers are super solid and have come out really nicely. In fact, I would say these might have come out even nicer again than the last ones. And then finally, we've got the texture. So 3D Print Life claimed that it's had a bone or a sandstone sort of look to it. I can sort of see that. I mean, it's going to depend on what color you go for as well, because they sell a range of colors for this filament. But it's slightly more matte effect than the traditional PLA look. But the texture is really nice and has come out really, it's smooth but is a bit more matte. So yeah, I really like that. Let's have a look at the last one. And finally, we've got the NonOilen, which is by Fillamentum. So on this one, the detail again has come out really nicely. Similarly to the last one, there is a tiny bit of issues with the top of the scales on the tail, which I am again pretty sure it's due to the stringing. So as soon as you refine the settings for this filament further and get rid of the stringing, that detail is going to be absolutely spot on, so that's not an issue. And again, with the antlers, super strong, nice finish, no artifacting up there, so that's come out nicely. And then with the texture, I actually really like the look of this. So of the 4 filaments, this is the only one that isn't available in a range of colors. It's only currently available in this, the natural color. But I actually really like the look of it. It's nice, shiny. It's almost like silk. It's like solid silk, but it comes out really nicely. So again, all 4 of these I think have come out really well. So with the texture and detail tests done now, there's not much in it. They all look fantastic. The only issue was with the 2 biofilaments. On the top of the scales on the tail, there was a couple of issues, but that was just due to stringing. And that's only as a result of me using the manufacturer recommended print settings for those filaments. I've obviously used PLA a lot, so have refined my settings for that to make them a better print. But with the 2 biofilaments, they're new to me and I've only refined them a bit from the manufacturer settings. They're pretty much the default settings on those. So as you get better settings, you're going to get rid of the stringing and then they'll print pretty much the same. So that's all the tests out of the way. So how did they compare? So with flexibility, the biofilaments were very slightly more flexible at the thinner end, but other than that, they were all pretty similar. With strength, again, the PLAs were stronger than the biofilaments, but again, they were in the same ballpark. They were all very similar. With dimensional accuracy, they were all pretty much spot on across the bar. There wasn't a big difference between them. But with the Alga filament, there was that issue with the vertical bars not printing. And I did print that a couple of times just to check that it wasn't a one-off thing. And that does seem to be as a result of probably the print settings, but also the filament itself struggling with that style of print. The non-oilen print did have a little bit of artifacting on the edge, but it wasn't a big deal, and especially if it's a practical print, it's not going to be a problem. Pretty similar across the board, with the exception of that failure on the Alga print. With the texture and detail settings, it's the same again. They're all pretty much as good as each other once you get to the point that you've refined your print settings for the biofilaments as good as you have with the PLA. With that, it means that being biodegradable doesn't mean that your filament's going to be much weaker and certainly not less accurate than standard PLA. And that means there's even less reason to not print with these more environmentally friendly materials. One reason, however, is the lack of color options. I mentioned earlier that Alga is available in a range of colors, but it's not going to be as diverse as what's available for PLA. As these filaments become more popular, the producers are obviously going to put more effort in and they will start producing a range of colors for them. But until then, that's not going to be an option. If you did want to print in another color right now and painting wasn't an option, bear in mind that painting these are going to affect the recyclability depending on what you paint with, then you could use them as a test print. You could do your test prints with your biodegradable filament, and then once you're happy with your model, just print that in your desired color, so you don't then have an entire bin to send off to landfill. You may be thinking, oh, that's all very well and good that these prints are fine straight off the bed, but they're designed to decompose. Surely they're not going to stand the test of time. Well, biodegradable filaments are designed to decompose, but only under the right conditions. However, in my next video, I am going to be putting that to the test. I'll be doing a series of prints in the same materials covered in today's episode, and one set is going to be put in a sunny window and left there. The other set is going to be put outside, exposed to the wind, the rain, the snow, all of the elements, and that'll be left there. And then a month later, I'll bring them all in, and then they're each going to be run through a series of tests to see how each filament puts up with those conditions. In the meantime, if you've got any questions, if you've got any ideas or thoughts that you'd like to share, please pop them in the comments below. Otherwise, don't forget to like and subscribe, and I'll see you guys next time. Thanks very much.